Hello, this is Mrs. Schroeder, returning to section 13 to talk about some physical properties of solutions. Our objectives today are to talk about electrolytes, non-electrolytes, and how they are different. Also talk about how a solute affects the freezing point and boiling point of a solution. Something called freezing point depression and boiling point elevation. We're going to talk about surfactants also and how they stabilize emulsions. So some different technologies, some different words we're going to talk about today. We've heard this term before, like dissolves like. So how can you get grease? You have grease on your hand, working on your car, working on your bike, you have grease all over your hands. How do you get that off? We know that grease is a non-polar compound and doesn't dissolve in water. Our washing machines use water, so what do we have to do? The reason we use laundry soap is what's called a surfactant. It's a substance that concentrates at the interface between the two phases. So it works in both phases. Soap is considered a surfactant. Soaps are sodium potassium salts of fatty acids. A long time ago they used to actually make those out of like pig fat. They would use that to make their soap. Now we have nicer ways to make it. But we have on a soap molecule, right down here, you'll see this end right here. All of these are carbons. It's a long carbon chain. And these dissolve in the nonpolar. So it dissolves in the oil on this end. And this end over here with the positive and negative charge dissolves in the water. So we have this bubble of soap essentially surrounding a droplet of oil. So you have a drop of oil, you have a soap kind of surrounding it with all these tails into it. And then we have the water out here, dissolving in that. So we have this emulsion, these droplets form. Now tap water is what's called, it contains minerals. We call this hard water. Some of you may have water softeners in your houses. Water softeners help remove these things, calcium, magnesium, and iron, which are found commonly in tap water. The reason why, because when you put those with soap, you make insoluble salts. Insoluble salts, as you know, are things that don't dissolve. In your bathtub, in your sinks, they form what we call soap scum. It's these minerals with the soap. So not everybody wants to use a softener, water softener for their water. So scientists have developed synthetic detergents. These are a little bit different than soap. They don't react to form an insoluble salt. They're actually soluble salts. At the end of the tail, the nonpolar end, they have a sulfonic acid. So soaps have this with a COOH, a carboxylic acid. Organic soaps have, or synthetic detergents have this sulfonic acid, so it will not form the insoluble salts. We call soaps and detergents emulsifying agents. An emulsion is something, remember we talked about colloids, things that are intermediate size. They're distinctly different phases, but they're not big enough to settle out. Soaps and detergents make emulsions. The oil that's in there turns into those droplets and it becomes this separate phase, but it can't settle out like you would see it in a suspension. Conductivity is the ability to conduct an electric current, kind of like what it sounds like. We know copper wire is conductive because that's what we use in our houses to run electricity. Sometimes solutions are conductive, depending if it contains charged particles. If it does, it is conductive. The electrolyte is the charged particle, essentially. It's the thing that dissolves in the liquid solvent and gives the ions that allow it to conduct electricity, and we call that an electrolyte. Strong electrolytes are things that dissociate completely, and we have weak electrolytes. They provide a few ions. They're partially conductive, but not really strong. They have weak electrolytes. Some of that material is dissociated, but not all of it. A non-electrolyte then would be the thing that does not allow electricity to flow at all. Now moving on, we have something called colligative properties. These are properties of the solution that depend on the number of particles. the actual number of the physical particles in that of that solute in that solution. It doesn't matter what they are. It does not depend on the identity. When we put something like sugar is a non-electrolyte. It'll remain in the solution as a whole particle. But when we have something like electrolytes, they're going to dissociate into their ions. So sodium chloride dissociates into Na plus Cl minus. It has two particles. Calcium chloride has a calcium plus 2 chlorine ions, so it has 3 particles when it dissociates. So it doesn't matter which particles they are, they'll all act the certain way to change the properties of that solution. We have this term called molality. Notice it has an L in there. Molality, and we use a cursive M. You'll need to know this equation, write this down. Molality is the moles of particles divided by the kilograms of the solvent. In particles depends on this also. Okay? So moles of particles divided by kilograms of solvent. The reason we use that is because when we have when we put salt in water, it changes the properties of it. Salt in water, or salt on ice, will actually depress or lower the freezing point. The amount, delta TF, K is a constant, and it's depending on which solvent you have. So water has a certain K. M is the molality, the cursive M, and delta T is the amount that it decreases, how far it changes. So we'll be using this. Make sure you have this written down. And we also have something called boiling point elevation. When I add salt to water, it'll actually change the boiling point. So we know that normal boiling point of water is 100 degrees. If I add salt to it, I can raise the boiling point, which is why some people try to use salt in their water. They can cook it faster, can get the water hotter, so it might cook faster. Again, the formula looks very similar. Delta T boiling point is the amount the boiling point increases. Kb is a constant, depending on the solvent. And M is the molality in moles per kilogram of the solution. So we will have some problems that we're going to go through. I want you to pause the video and write these down. And when we come back to class tomorrow, we're going to learn how to do some of these problems. But this is your general plan to actually solve these problems. So pause it, pause the video, write them down, come into class prepared to try some of the problems, like this. Find the freezing point and boiling point of a solution containing 65 grams of sugar dissolved in 250 grams of water. Okay, so there's your instructions, and write those down. Make sure you have the equations written down also.